He's the sleepy Mr. B in this chapter 4 test that won't stop him from doing his best. He's got a job to do, and it's doing this test with you.
All right. Chapter 4 practice test. I caught a mistake right away on the first one, so my wording's a little different here than it is on the copy that you're looking at online, but the sentiment is still the same. So if a map showed a scale of 2 centimeters equals 15 miles, the total length on the map is 4 centimeters long. How far is that in the real world? So if I know that 2 centimeters is equal to 15 miles, I know there's going to be a proportional relationship. So if I multiply the number of centimeters by a number, I need to also multiply the number of miles by the same number. So to go from 2 centimeters to 4 centimeters, I had to double that, or multiply by 2. So I need to do the same thing here with 15. That's times 2. I don't know why I put that dot in there. So 15 times 2 would give me 30 miles. So 4 centimeters on the map would be 30 miles in reality. The next one says, what if it is 9 centimeters long? So this one's a little tougher because it's harder to figure out what do I multiply 2 by to get to 9. So I need a number that when I multiply by 2, I get to 9. In this case, one thing that we've seen a little bit of in class is we could say, okay, we need 2 times some number x equals 9, and we could solve for that x. So since it's 2 times x, I can actually divide both sides by 2. It's the inverse operation. So that creates a 1 here, which gets my x by itself, which is what I want, because I want to know what x is. And as long as, if I do it over here, I have to do it over here. It's okay as long as I do it over here. So then 9 over 2. Well, 9 over 2, we know 2 goes into 9 4 times with a half left over, so it'd be 4 and a half. You also could have said, in this particular case, you might have been able to see that 2 goes into 9 4.5 times. So now that I have that 4.5, I need to go and use that with my 15 miles. So I need to go 15 miles times 4.5. The easiest way to do this would be to change 4.5 into an improper fraction. So it's 15. 2 times 4 is 8, plus 1 is 9 over 2. We treat 15 as 15 over 1 because that's what it is. 15 times 9. I have to go and do this one over here. So 15 times 9. 9 times 5 is 45. Okay, the 4. 9 times 5 is 9, so it's 135. So it's going to be 135 over 2. I divide 135 by 2, and that is going to be 67.5. All right, moving down to number 2. We have a order of operations problem here. So there's a lot of parentheses in this one. Remember, in order of operations, we start with parentheses or grouping symbols, but we have to start on the inside of them, so the most inside one. So in this case, I'm going to start over here where I see negative 4 minus 8. So I have 4 negatives. I'm taking away 8 positives. So I'm going to go further in the negative direction. And that's going to give me negative 12. I'm going to keep those parentheses. All right. Now over on, I can do either group of parentheses right now because they're separate. So I'm actually going to do them both in the same step. So I keep the 4 on the outside. 3 times a negative 12 is going to give me a negative 36. It's 3 groups of negative 12. And over here, since it's subtraction and addition, I'm just going to go left to right. So 3 minus 6 gives me negative 3. Plus 2 is going to give me negative 1. Now I multiply 4 times negative 36. It's a positive times a negative, so I know my answer is going to be negative. I know that 4 times 3 is going to give me, well, 4 times 30 is going to give me 120. And 4 times 6 is going to give me another 24. So 120 plus 24 is 144. So minus 144. and then a negative 5 or a minus 5 times a negative 1. We know that's going to become a positive 1. Or, a plus 5. Positive 5. So now I have a negative 144 plus 5, and that gives me negative 139. I'm a little tired this morning. There you go. All right, moving over here to B. Another order of operations problem. This one has an exponent in it. If we remember in the order of operations, if I were to write out PEMDAS, which, remember, addition and subtraction are the same group, and multiplication and division are the same group. But exponents come right after parentheses. In this case, they're separate, so it doesn't really affect you, but still, we can go ahead and do 4 divided by 2 would give me 2. Now I can go ahead and do my exponent as well. So 4 to the third, when we raise a number to the third, it means we're going to multiply by itself 3 times. So 4 times 4 times 4. The first two 4s would give me 16. And 16 times 4 gives me 64. So now I have 2 times 64. And 2 times 64 gives me 128. Unfortunately, I wrote kind of close to my next problem, but that's okay. For number 3, it says, what is the perimeter and area of the shape made with the tiles at right? So we went over all these algebra tiles in class. Unless you're watching this before we go over the algebra tiles in class. But we're going to go over them. So we know that let me write these down here. The thin rectangle represents x in terms of its area. And that's because these sides, the long side is x long, and the short side is 1 long. We know that the little square is meant to be just 1 by 1. And the big square, not drawn to scale here, is x by x with an area of x squared. So it represents x squared. But in this case, in the first one, we're just talking about perimeter. So we're just going to go around the outside. As I go around the outside, I'm just going to write what each length is, and then I'll write them in an expression over here. So up here at the top, that is x long. Again, I'm sorry that I wrote this so close. We'll draw a line here so we don't get confused. So x long. This little side right here is 1. This side here is 1 as well. Don't forget to count both of those. This is 1. Forgive the gap. There's not really a gap there. This is x, 1, and 1. This side here, like I said, of x squared is x, 1, 1, 1, 1, and 1. And I'm actually going to say right here is 1. We're going to need to talk about this side. So, this side right here, if we had the whole side, it would be equal to x. But we have part of it blocked off by this side. And we know how much we have blocked off. We have we have 1 blocked off. So what we can actually call this length right here, I'm going to write it on the inside. This line right here would be x minus 1. Because the entire line would be x, but we have 1 taken away because it's covered up right here. We make up for it out here with this one, but nonetheless, it's still taken up. So now I need to add up all these numbers to find my perimeter. So I have x. I'm just going to do all the x's first. Plus x, 1, 2, 3, and then plus x minus 1. And now how many 1s do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So I'm going to add 11. Now we'll just go ahead and simplify here. So we can combine like terms. We know we have 1, 2, 3, 4 x's. And I have a minus 1 and a plus 11. So one of those, that negative 1 or the minus 1 cancels out one of the 1s from 11, and I have just 10. All right, for the area, we're just going to count the area. I told you that this space was x. This one was x squared. And this is 1, because this 1 by 1 square is just 1. So let's see what we have. We have we'll start with our x squared. We have 1x squared. We know that. Write that down over there. Next, let's see how many x's we have. We have 1, 2, 3 x's. So we're going to add 3 x's. And then finally, we have 2 1s. So we're just going to make that 2. And that would be the area that's represented. All right, moving on. Number 4. I got a little lazy with the names. Just having a little bit of fun with them. Female person empties her bag of tiles on her desk and notices she has 5 large squares, 6 skinny rectangles, and 8 small squares. Write an algebraic expression that represents what she has on her desk. It has to be with x's and plus signs. So we're looking for an algebraic expression. Again, I'm going to start with the large squares because I know the large squares are x squared. We have 5 of those. So I have 5x squareds. I'm going to add the 16 skinny rectangles. So that's 16x because the skinny rectangles are each x. And then there's 8 small squares, so I'm going to add 8. There's my expression. That's the expression right there. I don't need an equal sign because it is just an expression. Next, male person passes by. He removes 3 large squares, 15 skinny rectangles, and 2 small squares from her desk. Oh, I didn't change the name. From her desk. Write an algebraic expression representing what he took. So, in this case, we don't need to worry about the fact that he's taking it. We just want an expression of what he took. So we have 3 large squares. That'd be 3x squared. We have 15x, because those are skinny rectangles, and then 2 small squares that he took. Moving down, it says, write an algebraic expression representing what female person has left. So now that this has been taken away from this, what's left? So she had 5 big squares. He took away 3. That leaves me with 2 big squares. She had 16 rectangles. He took away 15 of them. So now there's only 1 left. And I don't actually even need to write that 1. If I just write x, that implies that there's a 1 in front. And if he had 8 small squares and he took away 2, that leaves me with 6, or leaves her with 6. And there's my expression for what she has left. Now we need an algebraic equation showing what female person started with, what was removed, and what was left. They're really trying to walk you through here this problem. So they're giving you all the pieces to get to this down here. So we're going to start with what she started with. 5x squared plus 16x plus 8. We're going to take away this right here because this is what male person took away. So we're going to subtract it, and we're just going to put the whole thing in parentheses. Now it's an equation, so we have to put what it's equal to, and we already figured out what it's equal to. It's equal to 2x squared plus x plus 6. And there's an algebraic equation showing what she had left. All right, moving on. Still having a little bit of fun with the names. Dude man bought 3 pounds of rice, and he paid $14.22. And last week he bought only 1/2 a pound and paid $2.37. Is the relationship between the pounds of rice and the cost a proportional relationship? How do you know? There's a few ways here we can check to see if it's a proportional relationship. One is to see if the ratio of the cost to the number of pounds remains the same. And another is to see if when we multiply the cost by whatever number we need to multiply to get to the larger cost, if that's the same number we multiply 1/2 by to get to 3. So let's use that method first. So from 1/2, to get from 1/2 to 3, I need to multiply that by 6. So 1/2 times 6 would be 3. We know that. So what we need to see now is, okay, if I multiply 2.37 by 6, do I get 14.22? So 2.37 times 6. 6 times 7 is 42. Carry the 4. 6 times 3 is 18. Plus 4 is 22. And 6 times 2 is 12. Plus 2 is 14. I have 2 numbers behind the decimal point, so I will put it there. And sure enough, that is the same number that we have up here. So we already know that yes, it is proportional. But in case you wanted to check it a different way, or you might want a different method to use on your actual test, the other thing we can do is we can compare the ratios. So 14.22 over the 3 pounds of rice that were bought. And then 2.37 over 1/2, which I know is a little weird to put a fraction down there, but it's totally okay. And again, to check these, you would end up doing the same thing you did over here. So I would go ahead and I would say, okay, well, what do I have to multiply? Well, either we could divide them down, which if you have a calculator is fine. I'm not going to use a calculator right now. Or we could divide. We could say I have to multiply 1/2 by 6 again to get up here. So I'd multiply the top by 6 again. And we already checked that. We know it's equal. What is the unit rate for rice? We need to find out how much you pay for 1 pound here. So since we know that $2.37 is a half a pound, let's figure out what it is for 1 pound. So we're going to multiply both these in a proportional relationship. If we multiply one number by something, we can multiply the other number by the same thing. So 1/2 times 2 would give me 1. So 237 times 2 would give me 474. And that is the unit rate. So it's $4.74 per pound if you want to write it accurately. Or, yeah. Okay, so letter C. Next week, BroPal plans to buy 2 pounds so that he can share the rice with his visiting cousins. How much will the 2 pounds cost him? Show your work and or explain. So we've already done quite a bit of work here. We know the unit rate is $4.74 for 1 pound. Now we just got to find 2 pounds. So again, multiply both of them by the same number. I get a 2 on the bottom, which is what I want. 474 times 2 would give me 8, and then 9.48. 9.48. So it's $9.48. Fantastic. Moving down. Letter 6. Elf Goat is our new character. Elf Goat made a quick sketch of its room, and it added some quick measurements shown below. If the grid represents square feet, use Elf Goat's sketch and the measurements to draw an accurate scale drawing of its room. We assume that the room is a rectangle, and as our, it doesn't need to say her, it's an Elf Goat's not necessarily a her, its bed, called Elf Goat in it. And dresser, and all measurements are in feet. All right, so we know these measurements are all in feet. We know that we're going to say each one of these squares represents a, so I'm actually going to put my square. So I'm going to say 1 square equals 1 foot. Since we don't know how big the squares are, I can't actually put a scale with a measurement over here, but that'll do okay. I like having a scale down there. So we're going to draw this to scale. First of all, we know that this side right here is 15. We know it's a rectangle, so we're going to have to go 15 across. So if I start right here, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's where I end. That's where I began. Now I'm going to come down. I need to come down 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I go over 15 again. Just trust my number from before. And I can go ahead and I can just fill that in. I'm going to use my ruler so it looks nice, as I would expect you to do on a test. There we go. Right. So there's the outline of the room. Now we need to place the dresser and the bed here. So the first measurement I look at is I can see that it's 3 feet from the corner to the edge of the dresser. So I'm going to count over 1, 2, 3. That's where I'm going to start from. The dresser goes up 1 foot, so we just go up 1 square. And it's going to go over 3. So 1, 2, 3. And we bring it back down to the wall. I'm going to go ahead and skip out on the ruler for this one. I think I can do it. There we go. There's my dresser. Next, I need to do the bed. So the bed we can see is 2 feet from the wall over here. So if I go up 1, 2, that's where it's going to start. It's 7 feet. We're assuming it's a rectangle. So we're going to come down 7 feet long. 1, 2, 3, 4, 5, 6, 7. And we're going to go up 6 because it's 6 feet wide. 1, 2, 3, 4, 5, 6. There we go on that side. And there is your scale drawing of the room. Awesome. Continuing on, we're almost done. I know you're so disappointed. All right, so number 7. What operations are commutative? Explain and justify, or justify and explain your answer. Explain, justify and explain your answer. I need to work on some of these wordings here. I apologize. We'll just cross that out. So, what operations are commutative? The commutative property says that we can do the operation in any order and it doesn't affect the solution. So one example that I might use would be, we'll start with addition. So I'll say, okay, addition. If I take 2 plus 3, we know that equals 5. Well, if I switch those and I go 3 plus 2, I also get 5. So addition is commutative. I'm going to go ahead and circle it to signal that it's commutative. Next one, we try subtraction. I'm going to use a similar example. I'm going to go ahead and I'm going to say, if I start with 2 minus 3, 2 minus 3 equals negative 1. And if I flip those numbers so that it's 3 minus 2, now I get positive 1. So that is an example that is not commutative. You only need to find one example that doesn't work to show that it's not true. Okay, moving on to multiplication. I'm going to just keep using 2s and 3s. This seems to be nice, or working nice. So 2 times 3 equals 6. Let's flip it around. 3 times 2 still equals 6. Multiplication is commutative. And finally, division. 2 divided by 3 would be 2/3, or 0.6 repeater. And 3 divided by 2 would be 1.5, or 3/2. So that is not commutative. So we know that multiplication and addition are commutative, but subtraction and division are not. All right, finally, number 8. Consider this expression right here. We're going to draw a diagram either of Cecil's movements, so a number line, or of the positive and negative tiles. I'm going to go ahead and do the positive and negative tiles because I think it gets a little bit messy when you try to do the number line. So what I like to do is I like to write out. I like to write out the expression like this. So 5 plus 2. So I'm just writing it out big because what I'm going to do is I'm going to do the tiles underneath it. So I start with positive 5. I know that with algebra tiles that would just be 5 positives. I guess I don't have color here, so we're gonna put little plus signs in them so that we know that they're positive. Over here, I have 2 groups of whatever's inside this parenthesis. So what I'm gonna do is I'm gonna create what's inside the parenthesis, and then I'm gonna do it a second time. So I have 4. And then I have 3 groups of 2. So I can go 1, 2, 1, 2, and 1, 2. There's my 3 groups of 2. Now I have to multiply this whole thing here by 2, so I'm going to make it a second time. I'm just making the same thing I just made above. And again, these are all positive here. It's going to take me a moment while I write plus signs and everything. All right, and finally over here, I have 3 groups of -1. So I can just create -1 3 times, because that's all that means. And each one of these is a negative. Now we're going to go ahead and we can simplify it. So I'm going to cancel out. I have 3 negatives here. I'm going to cancel them out with any other 3 negatives. I'm going to just choose these ones because it's easier to draw a circle around them. And what I'm left with is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So I end up with 22 positives at the end. If you wanted to check your work, you can go ahead and go 5 plus 2 times 4 plus 3 times 2. 3 times -1. Or I guess really this would probably be checking your work over here. But nonetheless, if you want to see it solved in the equation, I have 5 plus 2. Inside the parentheses would be 4 plus 6. Plus 3 times -1. I continue going in the parentheses. So 4 plus 6 is 10. Notice that would be our 10 that was right here that was repeated. That's a 3. 5 plus 2 times 10 is 20. Again, there was 2 here. That would be the 20. Plus 3 times negative 1. The 3 times negative 1 we already knew was going to give us negative 3. That's our negative 3 right there. So we have 5 plus 20, which was this whole thing, plus negative 3. And we cancel out the negative 3 from the 20, so we can make that 5 plus 17. So at least it reflects what we did over here. And then 5 plus 17 is 22. I'll leave the tightrope diagram to you if you'd like to figure that out. Good luck.